In this video, I am discussing KSET PYQs on the topic sequences. Question is, consider the sequence even is equal to sequence even is equal to 1 plus 1 minus 1 whole raised to n 1 by n whole power n. Then limit n tends to infinity, superior of un is equal to limit n tends to infinity, inferior of un is equal to 1. What will be the answer? Now, concept is sequence, given sequence is here, un is equal to 1 plus minus 1 raised to n 1 by n whole raised to n. Here two cases arises. If n is even and if n is odd. If n is even, if first case, if n is odd, then 1 minus 1 by n whole raised to n. If n is even, 1 plus 1 by n whole raised to n. N odd, in this case, n even, in this case. This is standard result, very, very important. An and Bn are two sequences. Let An and Bn are two sequences. I am discussing standard result sequences. If limit n tends to infinity, an is equal to 0 and limit n tends to infinity, bn is equal to plus or minus infinity. In this case, then this is standard result. E to the power limit n tends to infinity an into bn. If we apply here, e to the power n is minus 1 by n into n. This get cancelled, e raised to minus 1. This is e. This is inferior of an. Second case, 1 by n is there, an. E to the power 1 by n into bn is n. This get cancelled. This is e. This is superior. Simple result. Where is the answer? Yes. In option 4, limit n tends to infinity, superior of un is equal to e. Limit n tends to infinity, inferior of un is equal to 1 by e. This is the right answer. Remember this result. Next question. KSET 2024. Question is limit n tends to infinity 1 by n square plus 2 by n square plus n by n square is. Here limit n tends to infinity, take 1 by n square common, this becomes 1 plus 2 plus 3 plus 4 plus and so on plus n. We know this is summation of n. Limit n tends to infinity 1 by n square. This value becomes n into n plus 1 by 2. This is equal to limit n tends to infinity n square 1 plus 1 by n square into 2. This n square get cancelled. Limit n tends to infinity 1 by 2, 1 plus 1 by n. If you apply limit, this term becomes 0. Answer is 1 by 2. This is the right answer. Simple question. KSET 2023 question. Limit n tends to infinity 1 by root n into 1 by root 1 plus root 3 plus 1 by root 3 plus root 5 plus and so on plus 1 by root 2n minus 1 plus root 2n plus 1 equals. Yes. Limit. See, limit n tends to infinity 1 by root n 1 by root. I write like this, root 3 plus root 1 plus root 5 plus root 3, same as it is. Root 2n plus 1 plus root 2n minus 1. Rationalize this. Limit n tends to infinity 1 by root n 1 by root 3 plus root 1 and 2 root 3 minus root 1 divided by root 3 minus root 1 plus 1 by root 5 plus root 3 root 5 minus root 3 divided by root 5 minus root 3 plus and so on plus 1 by root 2n plus 1 plus root 2n minus 1 and 2 root 2n plus 1 minus root 2n minus 1 divided by root 2n plus 1 minus root 2n minus 1. This is equal to limit n tends to infinity 1 by root n root 3 minus root 1 divided by 3 square minus 1 square. Root 3 square minus root 1 square means 2 plus this becomes root, this is 5, root 5 minus root 3 divided by 2 plus and so on plus root 2n plus 1 minus root 2n minus 1 root this this term get cancelled. It becomes it also root 2. Take 2 outside. 1 by 2, 1 by root n, limit n tends to infinity, root 3 minus root 1 plus root 5 minus root 3 plus and so on plus root 2n plus 1 minus root 2n minus 1. This term, this term, this term, this term, all terms get cancelled. Left 1 by 2 limit n tends to infinity 1 by root n into root 2n plus 1. 1 by 2 limit n tends to infinity 1 by root n. Take root n common. 1, 1. This is root n common becomes 2 plus 1 by n. This root n get cancelled. If I apply limit, it becomes 0. This root 2, here root 2 get cancelled. Answer is 1 by root 2. 1 by root 2. There is answer. Yes, 1 by root 2 is the answer. KSET 2023 question. The sequence minus 1 raised to n is minus 1 raised to n. Two cases arise. This becomes minus 1 if n is odd, plus 1 if n is even, oscillating between minus 1 to plus 1. Therefore, sequence an lies between minus 1 to plus 1, bounded above by plus 1, bounded below by minus 1. Therefore, it is bounded sequence. This is the right answer. Next, if x1 greater than x2 greater than 0 and xn plus 1 is equal to 1 by 2 xn plus xn minus 1 for n is equal to 3, 4, 5 and so on, then limit n tends to infinity xn. They are asking value of this. Here 3 cases arises. If first case x1 is equal to x2, second case x1 less than x2, third case x1 greater than x2. They are giving x1 greater than x2 case. This is a standard problem. Very, very important. I will post the answer in our Telegram channel. For the sake of this, answer is 1 by 3 x1 plus 2x2. Here concept is monotonically increasing, monotonically decreasing, monotonic sequences. Question based on monotonic sequence. Next question, 2021. If a greater than k, then limit tends to infinity a minus 1 whole raised to n plus a minus 2 whole raised to n plus and so on, a minus k whole raised to n whole power 1 by n. This is Cauchy second theorem. Cauchy, based on Cauchy's second theorem and monotonic sequence. This is monotonically decreasing sequence. Monotonically decreasing sequence converges to its infimum. Therefore, answer is this. Or else, monotonically decreasing sequence converges to its first term. Here a greater than k is there, value is decreasing, therefore monotonically decreasing sequence converges to its infimum. Therefore, answer is a minus 1. Simple question. Next, KSET 2021. Define A1 is equal to 1 and AN is equal to smallest prime factor of n for n greater than 1. Then the sequence AN. Here they given A1 is equal to 1, AN is equal to smallest prime factor of n for n greater than 1. That means 2, 3, 5, 7, 11, 13, 17, 19, like this. Then the sequence AN converges absolutely. This is wrong. Converges but not absolutely. This is also wrong. Diverges. Yes. Value of this is diverges. AN is equal to, if you put AN is equal to n, condition, these two condition, if we apply limit n tends to infinity, AN is equal to infinity. Therefore, this sequence is diverges. Next, the value of KSET 2020 question, the value of limit n tends to infinity, n raised to root 3 divided by 1 plus root 2 whole raised to n is. Simple question. Here an is equal to n raised to root 3 is there divided by 1 plus root 2 whole raised to n is there. See, for the sake of simplicity, take an plus 1 is equal to n plus 1 whole raised to root 3 divided by 1 plus root 2 whole raised to n. whole raised to n plus 1. Next, an plus 1 by an is equal to n plus 1 root 3 divided by n 1 plus root 2 whole raised to n into 1 plus root 2 into 1 plus root 2 whole raised to n divided by n raised to root 3. This get cancelled. 1 n plus 1 whole raised to root 3 divided by n raised to root 3 1 divided by 1 plus root 2. This becomes 1 plus 1 by n whole raised to root 3 1 divided by 1 plus root 2. If I apply limit n tends to infinity, an plus 1 by an is equal to, this value becomes 0, value of 1 plus root 2. This is less than 1, converges to 0. Converges to 0. Answer is C. Next question is, limit n tends to infinity 1 by n into 1 by 2 plus 2 by 3 plus and so on plus n by n plus 1 is equal to, this question is based on Cauchy first theorem. Let an is a sequence converges to an, then limit n tends to infinity an is equal to a, then its arithmetic mean a1 plus a2 plus and so on plus an also converges to same limit a. That means here an is equal to, nth term is n divided by n plus 1. If I apply limit n tends to infinity, an is equal to, take common n, 1 plus 1 by n. This get cancelled. Value is 1. Answer is C. Next, 2018 question. I will discuss this question in the next video. If you like the video, hit the like button. Subscribe this channel for more videos. Thank you for watching.